These are the answers for the 2.9 Kinetics Fact File. Question 1. Which one of the graphs below most accurately represents the distribution of molecular energies in a gas at 500 Kelvin if the dotted curve represents the distribution for the same gas at 300 Kelvin? So we're looking for the first graph and then the second one to be slightly higher and to the left, which is C. Number 2, the diagram shows a Maxwell-Boltzmann distribution curve for a mixture of sulfur dioxide and oxygen at temperature T. EA is the activation energy. On the diagram, sketch the distribution curve for the same reaction at a higher temperature. So we're looking for the peak to be to the right and slightly lower. So then use these distribution curves to explain why the reaction between sulfur dioxide and oxygen is faster at higher temperature. So we have a greater, the number of molecules with energy greater than the activation energy increases. So 1 mark for that and 1 mark for that. And with the graph actually, there are 2 marks for it. The first mark is for being to the right, and that's the peak, shifting to the right, and the second mark is for the fact that it is lower. Okay, so use the distribution curve to explain the role of catalyst and why the reaction between sulfur dioxide and oxygen is faster in the presence of the catalyst. So the first thing you need to say is that the catalyst provides an alternative route. The second point is that that route is of a lower activation energy. The third point is then more molecules have more energy. I've already said more energy, so have energy greater than the activation energy. And finally, then the frequency of collisions between the SO2 and the O2 molecules increases. And there would be 1 mark for each of those 4 points. And finally, the Maxwell-Boltzmann distribution for a reaction mixture shown below. N is the number of molecules with the most probable energy, and EA is the activation energy. So which one of the following shows the effect on the activation energy and N of increasing the temperature? So remember, we drew this before, so it's to lower and to the right. So N then decreases, but the activation energy, the activation energy remains the same. So N decreases, that rules out these two, and the activation energy remains the same, which is A.